Good day, learners! Welcome back to General Mathematics Learned by Video series. This is brought to you by QuexBook Smart Mobile Learning and PerkDC Learn Hub. I am Engineer Rex Jason Agustin, and we are now on our 5th lecture video on simple and compound interest. This is still under Part 2 Basic Business Mathematics of our General Mathematics for Grade 11 Senior High School Students series. Our targeted most essential learning competency solves problems involving simple and compound interest. For the topic outline, we have simple interest problems, compound interest problems, and effective rate of interest. In line with the MELC, our learning objectives are to be adept in solving problems involving simple and compound interest, and to understand and compute for the effective rate of interest. Let us have example number 1. Mikael buys a bicycle for the new normal from a merchant who asks 8,000 pesos at the end of 60 days. Cash in 60 days. Mikael wishes to pay immediately, and the merchant offers to compute the cash price on the assumption that money is worth 5% simple interest. What is the cash price today? The given are future value F, 8,000 pesos, nominal rate R, 0.05 or 5%, our interest rate per period is R over 360. This is for ordinary simple interest. Okay? Remember that for ordinary simple interest, we use 1 bankers year, which is 360 days. Okay? It's written here 5% simple interest. Now, you might be asking, why not use 365 days, which is for a normal year, or 366 days, which is for leap year? Okay? If it is stated simple interest and it is not clarified whether to use ordinary or exact simple interest, we use ordinary simple interest. Okay? Because if you come to think of it, there is no way in this kind of problem that we will be able to determine if that year is a leap year or not. Okay, so we use 1 banker's year, which is 360 days. N is equal to 60 days, cash in 60 days. And in this problem, we are required to solve for the present value P. What is the cash price today? Okay? For our solution, we use the formula F is equal to P times quantity 1 plus I times N. This is our formula for future value for simple interest computations. Transposing, we get P is equal to F over 1 plus I times N. And then substituting the given, that would be 8,000 over 1 plus 0.05 over 360 days times 60 days. We can cancel the unit days, and we will get the answer 7,933.88. Okay, just press this in your calculator and you should be able to get 7,933.88. Next, example number 2. Yuri is supposed to borrow 10,000 pesos from a loan firm at 15% simple interest. If the interest is deducted from the loan at the time that the money is borrowed and at the end of 1 year, he has to pay back 10,000 pesos, calculate the actual rate of interest. The given are future value F, 10,000 pesos. It is written here at the end of 1 year, he has to pay back 10,000 pesos. So 10,000 pesos is our future value F. Our N is equal to 1, no problem with that, at the end of 1 year. N is equal to 1. In this problem, we are asked to solve for I. Calculate the actual rate of interest. Now, some of you might be asking, isn't it that it's already given? We have here 15% simple interest. This is not our actual rate of interest. Okay? It's different from the one that we're going to solve. Now, how are we going to call this 15%? Let's consider it as discount. Discount is equal to 0.15 or 15%. Just like the discount that we get from stores. For example, if we are going to buy jeans or pants worth 1,000 pesos and the store offers 15% discount, instead of paying 1,000 pesos at that time, we just have to pay 850 pesos. 150 pesos is deducted from the original price, 1,000. Okay? That's discount. For our solution, we should first compute for the actual amount of money borrowed at the start. Because Yuri wasn't able to receive the supposedly amount of loan, 10,000 pesos, in the beginning. Yuri was only able to receive 10,000 pesos minus 15% of 10,000. He only received 8,500 pesos in the beginning. Okay, this is the present value of our loan. From the formula, F is equal to P times quantity 1 plus I times N, we get I, interest rate, is equal to F over P minus 1 over N. Then just substituting the given, we will have interest rate I is equal to 10,000 over 8,500 minus 1 divided by 1. Just press this in our calculators and we are going to get 0.1765. The actual rate of interest is 17.65%. Now, you see that if the interest is deducted in the beginning or at the start, the actual rate of interest gets higher. For example, number 2, the actual rate of interest is 17.65%. Alright? Let us have example number 3. If 1,000 pesos becomes 1,346.86 pesos after 5 years, when invested at an unknown rate of interest compounded quarterly, determine the unknown nominal rate. We have the following given: principal or present value P, 1,000 pesos, future or maturity value F, 1,346.86 pesos, frequency of conversion M equals 4, that is for quarterly compounding, compounded quarterly, and T is equal to 5 years. Okay? In this problem, we are asked to solve for the nominal rate R. Determine the unknown nominal rate. For our solution, we should first compute for the total number of interest periods N, which is equal to M times T. Substituting 4 for M and 5 for T, we get 20. The total number of interest periods N is equal to 20. We know the formula F is equal to P times quantity 1 plus R over M raised to MT. This is the formula for future value in compound interest computations. We can transpose P to the other side of the equation and we can write it as F over P is equal to 1 plus R over M raised to MT. Now, substituting the given, we will have 1 plus the unknown nominal rate R over 4 raised to 20 is equal to 1346.86 over 1000. Next, let's get the 20th root of both sides of the equation. 20th root of 1 plus r over 4 raised to 20 is equal to 20th root of 1346.86 over 1000. We can cancel 20th root and the exponent 20 on the left side of the equation. And then simplifying, we will have 1 plus r over 4 is equal to 1.015. 1.015 is the 20th root of 1346.86 over 1000. Okay? Now, transposing this equation to isolate r, we will have r is equal to 1.015 minus 1 times 4. Okay? Then we will be able to compute r is equal to 0.06 or 6%. The unknown nominal rate for quarterly compounding here in example number 3 is 6%. Next, let's have example number 4. How long will it take for an investment to double its amount if invested at rate of 6% compounded quarterly? We have the following given. Future value f is equal to 2 times the present value p. How long will it take for an investment to double its amount? There is no actual value given for f, and there is also no actual amount given for the principal p. We just have the relation f is equal to 2 times p. Okay? Nominal rate r is given 0.06 or 6%. And m is equal to 12 for monthly compounding. Compounded monthly. We are required to solve for t. How long will it take? So we are going to solve for time t. Okay? For our solution, we are going to use this formula, n is equal to log of f over p over log of 1 plus I. We used this formula in our previous lecture video. If you forgot about this, please check our previous lecture video, okay? Now, we know that I is equal to r over m. So, just substitute I with r over m, okay? And then substituting the given, we now have n is equal to log of 2p, that is our future value, divided by p. We can cancel p, okay, over log of 1 plus 0.06 over 12. We can just press this in our calculators, and we should be able to get 138.98. Okay, since the investment will earn interest at the end of every month, we should round this 138.98 up. Okay, we will have number of interest periods is equal to 139. Okay, n is equal to 139 interest periods or months. How did we know that it should be in months? Simply because it is compounded monthly. Okay? We know that n is equal to m times t. Solving for t, that is equal to n over m, or 139 over 12. T is equal to 11.58 years. For the investment to double its amount at 6% compounded monthly, it will take 11.58 years. Okay? In this problem, you can actually answer 139 months. Okay? If you want the answer to be in terms of months. In this case, we chose to answer in years, so t is equal to 11.58 years. Okay? Okay. Now let's have an example where there is simple and compound interest involved in the computation. Example number 5. A 2,000 pesos loan was originally made at 8% simple interest for 4 years. At the end of this period, the loan was extended for 3 years without the interest being paid, this time at the rate of 10% compounded semi-annually. How much should the borrower pay at the end of 7 years? Okay, let's take note of the given. We have, for simple interest computation, principal or present value of loan is equal to 2,000 pesos. Interest rate I is equal to 0.08 or 8%. 8% simple interest. And N is equal to 4 years. Okay? Now for the compound interest computation, we have nominal rate R, 0.10 or 10%, and M equals 2 for semi-annually. Says here 10% compounded semi-annually. Okay? And T is equal to 3 years. For the compound interest computation, T is equal to 3 years. It says here the loan was extended for 3 years. In this problem, we are asked to solve for the amount to be paid after 7 years. Let's call it F sub 7. Okay? The future value of the loan after 7 years. For our solution, it would be better to have a cash flow diagram to clearly see what's happening with the loan. At time is equal to 0, or at the beginning, a loan was made worth 2,000 pesos. After 4 years, the borrower has to pay a certain amount, let's call that F sub 4, which we do not know yet. To compute for this value, we will consider that 8% simple interest will apply. Considering simple interest, F sub 4 is equal to P times quantity 1 plus I times N. Substituting the values, 2,000 times quantity 1 plus 0.08 times 4, that is equal to 2,640. This is the amount that the borrower has to pay after 4 years. Unfortunately, he wasn't able to do so, so the loan was extended for 3 more years. Okay? Now that we know that F sub 4 is equal to 2,640, this loan will be extended for the next 3 years. But for these next 3 years, the interest will now be 10% compounded semi-annually. So to compute for F sub 7, we will use the formula F sub 7 is equal to F sub 4. F sub 4 will serve as the principal for compound interest computation times quantity 1 plus R over M raised to MT. Substituting the values, we have 2,640 times 1 plus 0.10 over 2 raised to 2 times 3. Using our calculator, we should be able to compute for 3,537.85. So the total amount of the loan after 7 years is equal to 3,537.85. This is the amount that the borrower has to pay after the 7th year. Okay? Let us proceed to our next topic, effective rate of interest. Effective rate of interest ERI can be denoted as ERI or lowercase I with the subscript EFF for the word effective. It is the actual or the exact rate of interest earned on the principal during 1 year period. We use the formula effective rate of interest is equal to 1 plus I raised to M minus 1, or effective rate of interest is equal to 1 plus r over m raised to m minus 1, where I with the subscript EFF is our effective rate of interest, lowercase I is equal to r over m, that is our interest rate per period, r is the nominal rate, and m is the frequency of conversions or the number of interest periods in a year. Let us demonstrate what effective rate really is by answering the following examples. Example number 6. What is the effective rate of interest of 8% compounded quarterly? We have the given nominal rate R is equal to 0.08 or 8%, and frequency of conversion M is equal to 4 for quarterly. We have here 8% compounded quarterly. In this problem, we are asked to solve for the effective rate of interest. Okay? We will have two solutions for example number 6. And for solution number 1, we will first compute for I, our interest rate per period, that is R over M, which is equal to 0.08 over 4, and that is 0.02 or 2% per quarter. Then next, we will just let P, our principal, to be 100 and T be equal to 1 year. Okay, we just assigned a value for our principal P, which is 100 pesos. Okay, since we let T be equal to 1 year, N, which is equal to M times T, will just be equal to 4. We have 4 quarters in 1 year. Let's just make this table wherein we have period in the first column and then interest earned at end of each period on the second column and future value at end of each period on the third column. For the first quarter, the money will earn an interest of 100 times 0.02 times 1, that is equal to 2 pesos. So after the first period, the money will become 100 plus 2 or 102. This now will become the principal for our second quarter computation. For the second quarter, the money will earn an interest of 102 times 0.02 times 1, that is equal to 2.04. So after the second quarter, the money will now become 102 plus 2.04 or 104.04. This will now become the principal for our third quarter computation. The interest earned for the third quarter is 104.04 times 0.02 times 1, which is equal to 2.08. At the end of third quarter, the money is now 104.04 plus 2.08 or 106.12. And then, this will become the principal for our fourth quarter computation. The interest earned for the fourth quarter is 106.12 times 0.02 times 1, that is equal to 2.12. After fourth quarter, the money will now become 106.12 plus 2.12, which is equal to 108.24. Okay, from this table of values, we can get the total interest earned, which is equal to the future value minus the principal P. 108.24 minus 100, that is equal to 8.24 pesos. The total interest earned is 8.24 pesos after 1 year. This is 8.24% of our principal 100 pesos, right? So, our effective rate of interest is 8.24%. We can say that 8% compounded quarterly has an effective rate of interest of 8.24%. Alright? Let's have solution number 2. This problem can be easily solved by simply substituting the given to the equation effective rate of interest is equal to 1 plus r over m raised to m minus 1. Okay, let's substitute the given. Effective rate of interest is equal to 1 plus 0.08 over 4 raised to 4 minus 1. Just press this in your calculators and you should be able to get 0.0824 or 8.24%. Okay, 8% compounded quarterly has an effective rate of interest equal to 8.24%. Okay? Okay. Let us have another example. Example number 7. Find the nominal rate compounded monthly which is equivalent to 12% compounded quarterly. We have the following given. For quarterly compounding, frequency of conversion M is equal to 4 and nominal rate of interest R is equal to 0.12 or 12%. We have here 12% compounded quarterly. I just use the subscript Q to indicate that it is for quarterly compounding. Next, for monthly compounding, frequency of conversion M is equal to 12. I just use the subscript M to denote that it is for monthly compounding. Okay? In this problem, we are asked to solve for the equivalent nominal rate for monthly compounding, or let's call that R sub M. Okay? We also actually have two ways to approach this kind of problem. For solution number 1, we should note that for two nominal rates to be equal, their effective rates must be equal. Again, for two nominal rates to be equal, their effective rates must be equal. So we just have to equate the effective rate of interest if it is monthly and the effective rate of interest if it is compounded quarterly. Okay? Effective rate of interest is equal to 1 plus r over m raised to m minus 1. Okay? On the left side of the equation, we have the effective rate of interest for monthly compounding. On the right side of the equation, we have the effective rate of interest for quarterly compounding. We can cancel minus 1 on the left side and cancel minus 1 on the right side. Okay? And then substituting the given, we will have 1 plus r sub m over 12 raised to 12 is equal to 1 plus 0.12 over 4 raised to 4. Okay? Next, we need to get the 12th root of both sides of the equation. Okay? 12th root of 1 plus r sub m over 12 raised to 12 is equal to 12th root of 1 plus 0.12 over 4 raised to 4. We can cancel 12th root and the exponent 12 on the left side of the equation. And simplifying further, we get 1 plus r sub m over 12 is equal to 1.0099. 1.0099 is equal to the 12th root of 1 plus 0.12 over 4 raised to 4. Okay? And then manipulating this equation to isolate r sub m, we will have r sub m is equal to 1.0099 minus 1 times 12. Okay, using our calculators, we can get r sub m is equal to 0.1188 or 11.88%. Okay? That means 12% compounded quarterly is equivalent to 11.88% compounded monthly. Okay? Now, how about our solution number 2? For solution number 2, we just need to note that for equivalent rates, they will earn the same maturity value for the same time. That's why they are called equivalent rates. They have the same maturity value for same time. So we can equate the future value for monthly compounding to the future value for quarterly compounding. Future value f is equal to principal p times quantity 1 plus r over m raised to mt. Okay? On the left side of the equation, we have here the future value for monthly compounding. On the right side of the equation, we have here the future value for quarterly compounding. We can cancel p on the left and right side of the equation, and we can also cancel t on the left and right side of the equation. Okay? Then substituting the given, we will have 1 plus r sub m over 12 raised to 12 is equal to 1 plus 0.12 over 4 raised to 4. As you can observe, from this point, our solution will now be the same for solution number 1, right? Our next step is to get the 12th root of both sides of the equation. 12th root of 1 plus r sub m over 12 raised to 12 is equal to 12th root of 1 plus 0.12 over 4 raised to 4. We can cancel 12th root and exponent 12 on the left side to get 1 plus r sub m over 12, which is equal to 1.0099. Okay? Then isolating r sub m, we will have r sub m is equal to 1.0099 minus 1 times 12. Using the calculator, we can compute r sub m is equal to 0.1188. The equivalent nominal rate for monthly compounding is 11.88%. Okay? 12% compounded quarterly is equal to 11.88% compounded monthly. Alright, that's it. Now let's check what have we learned. In this video, we were able to solve problems involving simple and compound interest. And we were also able to understand and compute for the effective rate of interest, right? Very good. This is our last video for the topic simple and compound interest. I hope that you've learned something from this series, and I also hope that you enjoyed watching these lecture videos. For our next lecture video, we are going to proceed to our next topic, simple and general annuities. For more related practice problems, you may use our QuexBook General Mathematics app available from Google Play Store and answer Chapter 4.